Okay, so this is the higher chemistry paper for 2018, triple award. So the first question asks you to do a balanced symbol equation between hydrochloric acid and sodium hydroxide. You could drop it if you needed to, telling you it formed sodium chloride plus water. So a really nice, easy question. It was balanced to start with. Next question then asks you to name apparatus X, which would be the pipette, and explain the point of the indicator, and that's the point of neutralization, and then to work out the mean of, so add them all up and divide by 3. Okay. There's a lot going on here. We want to follow this one by here. Okay. Sketch a graph, the total volume of 30 is added, so it's going to reach a peak in the middle, and state the volume of hydrochloric acid needs to change the indicator if half the original concentration was used. So if you look at this, the original peak is about 18, so 18 times by 2 would give you 36. Give a reason why iron in the reaction is molten. The temperature is so high so it causes the iron to melt. This is really easy. You've got 2 ions on this side, so you need 2 ions, okay. Aluminium then forms aluminium oxide, so you need to give the chemical equation for that again. If you needed to, use the table of ions, so it would be AlO3 plus O2 minus. State which substance has been oxidized. That's going to be aluminium because it's gained oxygen. It has no oxygen, ends up with oxygen. So when the mixture of magnesium oxide and aluminium powder is heated, there is no reaction. Okay, so that means that magnesium is automatically going to be the most reactive. Aluminium we know is more reactive than iron because it steals it away, so that's why we put them in that order. Lots of information here about this pipetting situation where we're looking for reactivity of metals. Put a tick next to what best describes the investigation the student is carrying out. What are the positions of the 4 metals in the reactivity series? To me, that's the best one. Give the letter which shows the results she recorded. It's B, okay. It can't be A. It also can't be... Also can't be this one because there's all sorts of displacement going on here. And then this one as well. So, it is B. It's a lot of work to do for 1 mark. Another student has said that this not all tests are necessary. Give one example of a test not needed. Copper plus copper sulfate because they're the same metal, no reaction. Describe one change the students would see during this displacement reaction. Silver particles will form, a clear to blue solution would also form. Give the balanced symbol equation for what's happening. So you've got silver nitrate plus copper will give you copper nitrate plus silver. Use the bar chart to describe how the difference between supply and demand of the fractions changes as the chain length increases. Smaller molecules have a larger demand but less of a supply. Larger molecules have limited demand but a larger supply. Then we're looking at the equation for cracking. Okay, so you start with C14, which means you need to end up with C14 on this side. Okay, so be careful of that. There's a 2 in front, so that's 2 times 2 is going to be 4. Okay, and that's going to be 2 times 2 is going to be 8. Okay, so you already know what that is, plus the 12. So 8 plus 12 is going to give you 20, and then 4 plus 6 is going to give you 10. Okay, so that means we've got hydrogen equaling 20, and we've got carbon equaling 10. We know it needs to equal 14 and 30. Okay, so difference there is going to be 4, so it's going to be C4, and then 20 is going to be 10, so C4H10. Name the hydrocarbon 4 carbons, no double bonds, so it's butane. State why ethane is considered an important raw material. It can be used to make all sorts of plastics. This then is combustion. Okay, first bit here, there are 3 carbons here, so put a 3 there because there has to be 3 carbons there. Okay, other thing is there's 8 hydrogens there, so we need a number times by 2 to give us 8, which would be 4. The total then number of oxygens on this side is 10, so we need a number times by 2 on this side to give you 10 oxygens. Loads and loads and loads of information about shale gas and how we can use it instead of petrol, stuff like that. Put a tick next to the box that best describes the statement. Identify the substance recovered during the fracking process, shale gas and contaminated water. Put a tick next to the box which is true. So fracking produces vast quantities of contaminated water. Really nice question here to draw the formation of calcium oxide in terms of a ionic bond. So 2 electrons now transfer over, because that's the metal transferring to the non-metal, so that becomes 2+ because it's lost 2. that becomes 2 minus because it's gained 2. Explain why both these compounds have higher melting points, and explain why the melting point of calcium is higher, okay? They both have really strong electrostatic attraction, so it's harder to break, requires a lot of energy. Ca is larger charge than Na, so the larger attraction, so a higher charge, harder to break. Explain why the bonding present in both forms make them as good conductors of electricity. They have a 3-carbon bond instead of a 4-carbon bond, so 1 electron is free, which means they can't transmit electricity. Okay, so first off, we know that each of these in terms of circumference is 0.26. There is 11 of them, so the total circumference is going to be 2.86, okay? To work out the diameter, we need to rearrange the equation, and we need to do circumference divided by pi, okay? They told you what pi was going to be. So that then gave us this number, 0.91 nanometers. We then needed to convert it to meters, okay? So that'd be 9.108 times 10 to the minus 9. Blank page. Really nice question here about the different stages of the contact process. First thing that happens then is oxygen combines with sulfur to make sulfur dioxide, and I've given the equation for you there. Sulfur dioxide then reacts with oxygen to make sulfur trioxide, again, given the equation. Sulfur trioxide can't react directly with water, so sulfur trioxide reacts with sulfuric acid to make oleum. That oleum then reacts with water to make sulfuric acid, and that's how you end up with sulfuric acid. Conditions: 2 atmospheres of pressure, 400 degrees, and a vanadium catalyst. Total energy needed to break the bonds and the reactants is 2587. Calculate the total energy needed to break the oxygen-oxygen bond. So we know that this one, they told you there's 4 of them, is going to be 209. Take away the total reactions by 209, so each oxygen bond is 495. Calculate total energy in the products would be 6 times by 523 gives you 3,138. Take that away from the reactants, so reactants is that. Take away that from products, that's minus 551. And then that's an exothermic, so your products are going to be lower. Which fertiliser leads to absorption of more nitrogen for a full 2,000 litre spreader? Show your workings. So for a full 2,000 litre spreader with the ammonium nitrate, you get 690 mass. If you times that by 34%, you get 234.6, okay? Do exactly the same thing. Remember their percentages, so 560 times by 46%, you get 2576. So the answer is urea. Put a tick next to the statement that best describes the main reason for this. Ammonium nitrate is better suited to the weather conditions than urea. 2 different equations here. Right, a balanced symbol equation for the reaction between ammonia sulfate and sodium hydroxide. They gave you the symbol equation, for ammonia sulfate, plus sodium hydroxide is NaOH. It will then make sodium sulfate plus water plus ammonia. You didn't need to work that out though, by the way, okay? They gave you all that, okay? The only thing they said was the gas that turns damp red, litmus paper blue, but we know that's ammonia, okay? Right, the ionic equation, you're looking at the one that is a solid, the one that's a solid, so you're looking at the 2 ions that cause it to become a solid, okay? Tough question there, tough question, okay? But we are towards the end of the paper. General formula for the alkane family, CnH2n plus 2. That's really important that you learn your general formulas. Draw an isomer of butane. So this one is then 1, 2, 3 propane, 2 methyl propane, because I put my methyl group there. What would happen if you add bromine across this double bond? The double bond would disappear, and instead you'll have 2 bromines. What would happen if you polymerize it? Again, the double bond would remove, you'd straighten it up, and you'd end up like that. Okay. Describe a chemical test that you could carry out positively identify the liquid as ethanol, include observations he would make. So acidified potassium dichromate would go from orange to green. Lots of information there about electrolysis. So the first thing you've got to do is 1, come up with your scale, 2, plot your points, 4 marks for that, okay? Use your graph to predict the mass of deposited using the current of 3.5. I went with a current of 3 and the current of 0.5 and added them together. Explain why the electrolysis keeps blue during the electrolysis process. Include electrode equations to support your answers. Copper sulfate remains in solution. The CO2 isn't used up. So even though this is happening constantly, the C2 ions leave and enter at the same rate. So these things are happening consistently. Calculate the moles of hydrochloric acid in 5.2 centimetres cubed of 1 mole per decimetre cubed. Okay, so that is the conc, that's the volume. Okay, make sure you divide your volume by 1,000, so that's really easy in terms of working out moles. Calculate the number of moles of calcium carbonate. Look up here, you've just worked out the moles of hydrochloric acid. They're in a ratio of 1 to 2, so divide it by 2, okay, because this one is the 2. That would give you 0.076. Then it says work out the mass of calcium carbonate in 1 tablet. Give answer in milligrams. So the first thing I did was work out the MR. They said the mass was, then we know from the other question we've worked out the moles to be that. So that's our moles from the previous question, that's our MR, so that will give us the mass, okay? That's in grams, times it by 1,000 to get into milligrams. Suggest an explanation for the difference between your answer in part C and the information on the packet. Other elements which react with acid are in the packet. Just looking along here, some blank pages and then some really important table of ions and a really important periodic table.